Good morning, everybody. Today's outline the class is model number 2, Introduction, Modeling Concept, and Class Modeling. The outline of the class is the introduction. So this chapter is taken from second textbook given in the syllabus, Object-Oriented Modeling and Design with UML, and written by Michael R. Pla and James Ramba. The outline is the introduction. So what do you mean by object-oriented modeling and design, OOMD? A way of thinking about problems using models organized around the real-world entity. The fundamental construct is the object. What do you mean by the object? Which combines both the data structure and behavior. The data structure may be arrays, trees, graphs, and behavior may be operations, average of the mass, and for example, this is one operation, draw, these are another operations. So object which combines both the data structure and behavior. So one example is given for understanding of the object and class behavior. See, in the given example, class is a collection of similar objects. For example, student class. Third, A division student class. So collection of similar objects. The object means each student is an object. In the given class, each student is an object. Here data are name, roll number, IMR, branch, etc. All these are the data for that object. Roll number 1 is a Ramesh, and here the data for that student is the name, roll number, IMR, branch, etc. are the data. So the behavior are the operation on this data. So average of IMR. So the operation here is the average of IMR. So class is nothing but collection of similar object, and object, each student is an object, and behavior are the operation on this data. So object which combines both data structure and behavior. The analysis, design and implementation phase of the system development can consider as a process and can have different stages. And object-oriented notation is used, and same notation applies at all stages of the software processes and development process. The use of object-oriented modeling is understanding the problems, communicating with the application experts, modeling enterprise, preparing your documents and designing programs and database. So the next is, what is the object orientation? The point is, what do you mean by object orientation? Short form is written as a OO. So object orientation is a mindset or approach of organizing the software as a collection of discrete objects, discrete means measurable objects, that incorporate both data structure and behavior, data structure and operations. There are four aspects of object orientation. One is identity, classification, inheritance, and polymorphism. The first one is the identity. What do you mean by identity? It means that data is quantized into discrete, distinguishable, and entities called objects. So the large data is quantized into this measurable, distinguishable entities called the objects. So example of object here given, the first paragraph in this chapter. So the chapter contains the number of paragraphs. The first paragraph is called as a one object. So many workstation is another object. White queen in the chess game. White queen is a one object. So object can be concrete such as a file system, or conceptual such as scheduling a policy in multiprocessing operating system. So each object has its own inherent identity. That is, the two objects are distinct. Means even if all their attribute values are identical. So both for roll number 1 and roll number 2, both are the same class and both are two different objects even if all their attribute values are identical. So in real world, an object simply exists, but in programming language, object has unique handle by which it can be referred. Languages implement the handle in various ways such as address, array index, or artificial number. Object references are uniform and independent of the contents of the object, permitting mixed collection of objects to be created, such as a file system directory that contains both files and subdirectories. It is a mixed collection of objects. So the second aspect is a classification. So what do you mean by classification? It means that objects with the same data structure and behavior are grouped into class. So all objects with the same data structure and operations are grouped in a class is called as a class. Third is students. So roll number 1 to 64 all are same data and behavior are grouped into class. That class name is given as a third A division. So class is an abstract that describe properties important to an application and ignore the rest. Any choice of the classes is arbitrary and it depends on the application. So paragraph is a class, monitor, chess. So each class describes possibly infinite set of individual objects. So that class contains infinite set of individual objects and each object is said to be an instance of its class. So each object is called instance of its class. An object has its own value for each attribute but share the attributes names and operations with other instances of the class. An object contains implicit reference to its own class. It knows what kind of things it is. So the third factor is the inheritance. It is the sharing of attributes, sharing of characteristics and operations is also called as the features among the classes based on the hierarchical relationship. So sharing of attributes and operations among the classes based on the hierarchical relationship. The student contains the some characteristics of the parents plus additional characteristics. That is called as a parent is called as a superclass and student is called as a subclass. A subclass has a general information that subclass is refined and elaborated. It can be refined and elaborate, and each subclass incorporates or inherits all the features of its superclass. So students inherits all the features of its parents. The ability to factor out common features of several classes into superclass can greatly reduce the repetition with the design and programs and is one of the main advantages of object-oriented technology. So one example is given. So one window is superclass and it contains the two subclasses. One is a scrolling window, another is a fixed window. So both superclasses inherits the features of the window. So both subclasses, scrolling window and fixed window, it inherits all the features of the window such as the visible region of the screen. And scrolling window adds a scroll bar and its object. So it contains additional characteristics, that is one is a scroll bar and another is a offset. So it is called subclass and superclass. And superclass can also be subclasses and inherits from other subclasses. So here superclass it also have subclasses and it inherits from other superclasses. The fourth factor is a polymorphism. It means that the same operations may behave differently for different classes. So same operations may behave differently for different classes. An operation is a procedure or transformation that an object performs or is subject to. Example, write, justify. This is one operation. Justify. Display and move. It is called as one operation is a procedure or transformation that object perform or subject to. An implementation of an operation by specific class is called a method. Because an object-oriented operator is a polymorphic, it may have more than one method implementing it, each for a different class of object. In real world, the operation is simply an abstraction or short form of the analogous behavior across the different kind of object. Each object know how to perform its own object. So in object orientation programming language, however, the language automatically selects the correct method to implement an operation based on the name of the operation and the class of the object being operated on. In the given diagram, polymorphism, an operation can have the same name in different class and produce differently in each class. So this is the all factors of the object oriented object orientation or core aspect of the object orientation. Thank you.